So when something is being moved, it may or may not be stable, and it may not be immediately obvious whether it will be stable or not. But you can imagine in this situation, say you've got an item that's say on a pallet and it's being lifted. If that item were to shift, the CG may move. It may cause it to tilt. That will cause the CG to move even further as the item slips further, and boom, catastrophically, the whole system say flips over and you drop the load. Very dangerous. So say to mitigate that, you might monitor the load points at each corner. And now if the load starts to shift, you know it, and stop, assess, reconfigure. Next slide. This shows a tank. You imagine this tank might have water in it, might have some kind of sludge or slurry, might even have a buildup on one side of the tank or the other. So it could be assumed that the CG is right in the middle. That may or may not be the case, or it may start in the middle and may move to one side or the other as the tank tilts a little bit. And as soon as it moves, that may cause it to tilt further. And again, may end up with this tank with one end pointing down at the ground. And if somebody's below it or equipment is nearby, you could see that something could get damaged or someone could be hurt. So again, monitoring not only the total weight, but maybe load points at the connections would tell you if things are shifting. And again, you could then make a decision whether to move forward or to stop and reconfigure. Next slide. So this shows a little bit about rigging. If you have an item that has a center of gravity, and here we show that it's being attached to at points that are below the center of gravity, depending where that hook is up above, you can either have an unstable or a stable load. And basically, if the hook is below where the center of gravity is, or the shackle, it will be unstable. And it may not be obvious because it may not be super obvious where the center of gravity is. So you can see by extending those lines, those slings on the lift points, so that the shackle is quite a bit higher than the item being lifted, you can ensure that the CG is below that. And here we show some angles. Basically, the idea is that angle A has to be smaller than angle B to have a stable load. Next slide. So this shows kind of a similar item being lifted, but using a spreader bar. The same thing applies, though. On the left, we'd have a stable configuration. On the right, it would be unstable. A little bit beyond the scope of this webinar to talk about stable and unstable rigging, but just to note, it's extremely important. Imagine whenever there's an unstable loading condition, things can shift, and as soon as they shift, get very violent consequences. So imagine if this thing were to tip over and drop something, and now the load completely unbalanced and maybe goes, swinging across the room or something, you damage equipment and injure people. So extremely important. Again, load monitoring is something that's really important. Might monitor at all of the attachment points to make sure that the loads are exactly as intended during the entire lift